Statistical analysis plans, and their tables, figures, and listings, are still written by hand for every study, slow, repeated effort, and the traceability from the protocol objective to the result quietly breaks. Use Case 2 asks for AI that generates this content accurately, consistently, and traceably, by combining AI with CDISC standards. Here is how. And you don't even need a structured data file. We paste the raw protocol pros, the kind you would copy from an M11 document, and click Extract with AI. The model reads it and pulls out the structure, the objectives, the endpoints with their visit schedules, the arms, the populations, and the estimands intercurrent event. Now, one click. From that AI extracted structure, the deterministic engine assembles the machine-readable plan, ICHE9R1 estimands, analyses, derived atom variables, sample size and sensitivity analyses, and the plan TLF outputs, every element published to the shared study bus with its own provenance record. Analysis populations resolve to the standard sets, intent to treat, safety, and per protocol, each defined under ICHE9 Section 5.2. The protocol's own enrolled population is folded into the ITT definition, so nothing is invented, and nothing is left to be confirmed. Each efficacy SDMAND carries all 5 ICHE9R1 attributes: population, treatment, variable, intercurrent events, and summary. Notice the intercurrent event, the disruption of treatment, with a treatment policy strategy, read directly from the protocol's own SDMAND, not a template, and linked back to its USDM identifier. Methods follow the endpoint and its measurement schedule. The primary endpoint, at week 24, is a single time point ANCOVA. But the longitudinal secondaries, measured at weeks 8 and 16, and from week 4 to week 24, correctly become a mixed model for repeated measures, MMRM, with LS means by visit. The plan also derives the atom analysis variables it will need, change from baseline, the baseline record flag, and the treatment emergent flag, and shows each one with its derivation logic and its SDTM source, ready for the programmers. This traceability table closes the loop. Use Case 2 targets. Every planned output traces back, through its analysis and its SDMAND, to a USDM objective and endpoint identifier, a genuine, linked chain from study design to result, not a claim. And every analysis projects into CDISC analysis results standard metadata, analysis set, treatment grouping, method, and result operations. Critically, it exports as a downloadable instance that we validate against the official CDISC ARS version 1 JSON schema, with National Cancer Institute controlled terminology codes bound, plus a define XML analysis results metadata fragment. And it is not a dead artifact. An independent consumer reparses that exported instance and drives our tables, figures, and listings generator, so the planned analyses execute from the exported metadata alone. Machine-readable conformance, checked, not claimed. And the plan is derived deterministically. Rederive and verify recomputes every element, and every provenance hash matches, same protocol in, identical plan out, chained with SHA-256 tamper evidence. That reproducibility is checked automatically, in continuous integration, against real protocols. Now the AI generation is deterministic where the statistics must be trustworthy, but AI is applied where it earns trust. Here, Live, Gemini reads this SAP and proposes the downstream atom datasets, ADSL, ADQS for the efficacy scales, ADAE for safety, ADEX for exposure, each mapped to a CDISC class, traced to its SDTM source, and cited to the atom IG. Every suggestion is human-reviewed. Across the plan, every element shows its citation in a reproducible provenance hash, with accept, edit, or reject controls. The reviewer accepts an element, and the audit readiness rises. The human stays in charge, reviewer-assisted automation, human QC required. A scored readiness assessment lists the cited blockers and an estimated review risk, so a team can see exactly what stands between this plan and a clean submission. And we report method concordance honestly. From the protocol structure alone, 3 of the 5 published pilot analyses match exactly, a 4th is a defensible modernization, a mixed model for a longitudinal endpoint, and 5 of 5 only when the protocol's own stated methods are honored, a ceiling, not a score. Every endpoint is mapped, with 0 placeholders, byte identical on every run, and patient data never leaves the machine. We ran 3 real DDFRA protocols, the CDISC pilot, Lilly's diabetes crossover, with the real drug and comparator names extracted from the interventions, and elections single-arm Wilson study. Real arm names, 0 to be determined placeholders, and identical output on every run. VinStat.ai turns a digital protocol into an auditable, traceable SAP, validated against the official CDISC schemas on the way in and out, AI combined with CDISC standards, end-to-end, reviewer-assisted, and ready for the people who sign off.